Factoring trinomials. Before we start factoring trinomials, let's do an example. We want to find two integers whose product is first 42, and the sum of those two integers is negative 13. So let's talk about how we're going to go ahead and do this. So if we created a list, so we'll go ahead and try with the number 42 first. So if I start out with 42, I'm looking for two numbers whose product is 42. So we can go ahead and do 42 times 1, or 21 times 2, 14 times 3, or 7 times 6. But those are only the positive integers, because we can also have negative 42 times negative 1, negative 21 and negative 2, negative 14 and negative 3, and negative 7 and negative 6. And because we want their sum in this example to be negative 13, we're going to go ahead and think about adding the negative values together. So which of these products is, as a sum, equal to negative 13? So the first two, this would be negative 43. This next one would be negative 23. Then negative 17. So it's this last one here, negative 7 plus negative 6, would get me a sum of negative 13. So the product, negative 7 times negative 6, is equal to 42, but negative 7 plus negative 6 is equal to negative 13. So the two answers are negative 7 and negative 6. So let's go ahead and move on and try negative 14. So we can absolutely create a list every time like this and think about all of the products that will give us negative 14 and add to 13. But we might want to be a little strategic about it and not try every single possibility. So what we're going to do here is think about the 14 and 1 scenario. So if I have positive 14 times negative 1, and how about negative 14 and positive 1? Well, if we want to add together to be positive 13, I'm going to have to choose positive 14 and negative 1 added together. So I'm going to erase this other option and scoot that down. So this is 14 plus negative 1. So my two answers are 14 and negative 1. Moving on to the next one, I'm looking at 54. So two numbers that multiply, their product is equal to 54, and their sum is equal to 15. So those two numbers are going to be 9 and 6. 9 and 6. So 9 times 6 is 54. And when we add together the positive 9 plus 6, I do end up with positive 15. So the answer here is the pair of numbers 9 and 6. Looking at negative 21, two numbers that multiply to give me negative 21 and add together to give me 4. So here I'm going to go ahead and go with 3 and 7, right? So I just have to pick the correct order. So I'm going to have one of them be negative and one of them be positive. So I'm going to pick negative 7 times positive 3, so that when added together, I end up with a negative 4. So negative 7 and positive 3 here. And then if I go ahead and think about 72, so I'm going to create a list for 72 up here. So 72 is all of the following products. So we can see there's a lot of different options. Well, none of these work because they're all positive, so when added together they won't be negative. So if I make all of these both negatives and I think about adding them together, I get negative 73, negative 38. Here, negative 24 plus negative 3 is negative 27. So this is, kind of close, and some students might make a mistake here because they see 24 and 3 and see 21, but they would both have to be negative to multiply to get 72, positive 72. But when added together negative, that's negative 27. Here I'd have negative 22, negative 18, and negative 17. So that means the answer here is none. There is not two numbers whose product is 72, but whose sum is negative 21. So we're going to take a close look at multiplying polynomials, because factoring is essentially undoing this process. So let's think about taking a binomial times a binomial here. So what we do is we take the first term, we take 2x, and we think about multiplying it by the entire binomial x minus 4. So here we can see this 2x and the binomial x minus 4. And then what we're going to do is we're going to take the second term from the first binomial. So we're going to take the positive 3, and we're going to multiply that by the binomial x minus 4. So 2x gets multiplied by the entire binomial, and positive 3 gets multiplied by that second binomial as well. And then what we would do is distribute in the 2x. So 2x distributes to both terms. That's where 2x squared minus 8x comes from. The 3 would distribute to both terms, so we get 3x minus 12. So we do have 4 terms. But the middle 2 terms combined together, these are like terms, and combined together to give me negative 5x. So I end up with a trinomial. So the process we're going to be working on is the exact reverse process. We're going to start with a trinomial, and we want to, in the first technique, create a polynomial with 4 terms first. So we're going to need to rewrite the middle term as 2 separate terms so that we can apply our factor by grouping technique to get us to this original product of 2 binomials. That's the goal. There are 2 methods of factoring ax squared plus bx plus c. As discussed, we can rewrite the term bx, the middle term, as the sum of 2 terms, so we can use factor by grouping. And the other method is the guess and check method, which is definitely quicker, but we're going to start with the more formal process of using this first technique. Let's walk through an example of factoring a trinomial using grouping. So here's our trinomial 3x squared plus 5x plus 2. And we need to figure out how to rewrite the middle term. So the strategy is we take the leading coefficient, the value in front of x squared, so that's 3, and the constant, that's 2, and we multiply them together. So that's where this 6 is coming from. Then we take the middle coefficient, the coefficient in front of just x, so 5, and what we try to do is find, as we did in that previous problem, 2 numbers that multiply to get us that 6 and add to get us that 5 from the middle coefficient. So here's creating that table of all the possibilities, all of the products that multiply to get us 6, and then checking whether or not those add to give us 5. And the one that works is 2 and 3. 2 times 3 gets us 6, and 2 plus 3 gets us 5. So what we do from there is we use those numbers 2 and 3 to rewrite the middle term. So here we have the original trinomial, and the middle term was 5x. But we're going to rewrite the middle term as a sum of 2 terms with the coefficients of 2 and 3. So 5x split into 3x and 2x, both positive, because positive 2 and positive 3. Now, quick note over here. Notice that I wrote 3x plus 2x rather than 2x plus 3x. The order doesn't really matter, but one way might be simpler to work with than the other. So here's what I mean by that. Now that we have 4 terms, we can apply factor by grouping. So our first group is now 3x squared plus 3x. And since I wrote 3x first, it's a lot easier to see the greatest common factor between these first 2 terms in this first group is 3x. And what we have remaining is x plus 1. Between the next group, I have positive 2x plus 2. So the greatest common factor is a positive 2. And I have remaining x plus 1. So now the greatest common factor is a binomial. Now I have an x plus 1 in common in both, so I can factor out that x plus 1, and what is left is that 3x plus 2. So there is my factorization. So to factor means to break down into a product. So x plus 1 times 3x plus 2, when multiplied out, gets us to 3x squared plus 5x plus 2. So we can go ahead and check by performing that multiplication. So first is 3x squared, and then outer is plus 2x, inner is plus 3x, and last is plus 2. So combining the middle terms, I get 3x squared plus 5x plus 2. So what's great about factoring is that we can check our work by multiplying our final answer. So I want to go ahead and be clear. I want to go back and box in the final answer here. And a quick note at the bottom, if there are no two terms that can be found to rewrite the middle term as noted in the chart, so if there's no values that work, the polynomial cannot be factored, and we say that it is prime. So now let's go ahead and actually write it all out, work one all out. Factor each of the following if possible. If not possible, write prime, and multiply to check your answer. So we have 8y squared plus 14y plus 3. So I'm going to take the leading coefficient and the constant term and multiply those together, which is 24. So I want two numbers that multiply to 24. And then I want two numbers to add to that middle term. So I want those same two numbers to add together to be 14. So I'm going to just go ahead and create a T-chart to organize my work here, to organize my thoughts. Now, of course, you can do this mentally if you choose. So I'm going to start with 24 and 1. So 24 plus 1 is going to add to 25. So that's not right. That doesn't work out. So I'm going to put a little X by it. Next, I'm going to go to 12 times 2. Well, 12 plus 2 is absolutely 14. So that one works. So there's no need to continue on. We know that we're going to rewrite the middle term using 12 and 2. So I'm going to rewrite my polynomial over here, my trinomial, and I'm going to take the middle term and rewrite it so that it has, it's a sum using 12 and 2 as the coefficients of the variable y. So this is going to split up to 12y plus 2y. And remember, the order doesn't really matter here, how we split it up. Don't forget to include the variable y, whatever the variable is in the problem. So I'm going to bring down my 8y squared, this was plus, and then I'm going to bring down my plus 3 as well. Once I have four terms, I move on to factor by grouping. So between the first two terms here, within the coefficients, I can factor out a 4, and within the variables, I can factor out a y. So I'm going to factor out a 4y, and I'm going to be left with a 2y plus 3. So dividing 8 by 4 gets me 2, and if I factor out one of the copies of y, I have one copy of y left here. If I divide 4 into 12, I get 3, and I'm taking out the only copy of y. Now within the next two terms, in the next grouping, here I can't pull out anything other than 1. So I can factor out a positive 1, which means I just have the exact same thing left over, 2y plus 3, which of course I needed to happen. I want to have that same exact binomial left over because that's the one that I'm going to factor out now. So since it's in common in both, I'm going to go ahead and factor it out. So 2y plus 3, and then what's left over is the 4y plus 1. So this original trinomial is equal to 2y plus 3, has to be in parentheses, times parentheses 4y plus 1. And we can go ahead and check our work. So we'll go ahead and do first, which is 8y squared. Outer is plus 2y. Inner is plus 12y. And last is plus 3. The middle terms combine, so we'll have 8y squared plus 14y plus 3. So that is the original trinomial, so we know that our factorization is correct. Let's go ahead and take a look at factoring p squared minus 9p plus 14. So we're going to have to take that leading coefficient, which notice in this example is 1, and multiply it to 14, positive 14. So 1 times positive 14 is 14. So we want two numbers that multiply to give us 14, but they need to add together to give us negative 9. So they need to add together to give us that middle coefficient, and it has to include the sign, negative 9. So two numbers that multiply together to give us 14, positive 14, and add to 9, well, they're both going to have to be negative if they're going to add together to be a negative 9 and multiply to give us positive 14. So let's try negative 14 times negative 1. Well, that's negative 15. That doesn't work. So how about negative 7 and negative 2? So we do end up with negative 9 when we add those together. So those are our two values. We have negative 7 and negative 2 that we'll use to rewrite the middle term. So here I rewrote the problem. We're going to split up negative 9p into negative 7p minus 2p. So I use those two numbers I found, but again I have to include the variable. This time it's p. Then I bring down my p squared and I bring down my positive 14. So that I have a total of 4 terms. Now I apply factor by grouping. So I'm going to go ahead and look at the first group and the second group. So within the first group, all I can factor out is a p, and I would be left with one copy of p and a minus 7. So taking 1 out of here and then factoring out this p leaves me with minus 7. And then here, I can factor out a negative 2, so I have negative 2, and what should be left, what has to be left, is p minus 7, or something didn't go correctly. But I take out the negative 2, I have a p left. If I divide 14 by negative 2, I do get negative 7. So I do have the same binomial left over. That's the one I'm going to factor out. So I have p minus 7 is what gets factored out, and what's left over is my p minus 2. So that is my factorization, p minus 7 and p minus 2. Now one of the things I want you to observe for this problem is that I ended up with p minus 7, so I'm going to go ahead and highlight that. So I have p minus 7 and p minus 2. And the two numbers that we originally rewrote the middle term with were negative 7 and negative 2. And that's not a coincidence. So this only works once you find these two numbers. They do go directly behind the variable. So p minus 7, p minus 2. We could have skipped this part here. But that only works, that only works if the leading coefficient is 1, if the number that's in front of p squared is 1. So if it's anything other than 1, we do have to go through this whole process. But if the leading coefficient is 1, then once we find those two numbers, we don't have to rewrite the middle term. We can just go ahead and substitute them into the factorization, p minus 7 and then p minus 2, using those two values. So let's go ahead and check. If I multiply here, I get first, that's p times p is p squared. Then outer, I have minus 2p. Inner is minus 7p. And last is plus 14. So I do end up with p squared minus 9p plus 14. And that is my original trinomial. Let's look at 6c squared minus 17cd plus 12d squared. So this looks slightly different from some of our other trinomials, but the technique, since we have a trinomial here, is still going to work the same. So we're still going to take that leading coefficient, 6, and the coefficient from the last term, so that's positive 12, and multiply them together. So we want two numbers that multiply together to give us 72, and then we want two numbers that add together to give us that middle coefficient, so we want to add together to be negative 17. So we'll go ahead and create our table, and we want to list all of those products that multiply to give us 72, keeping in mind that they will both have to be negative if I'm going to add together to be negative 17. So I went ahead and listed all of them out, and we can see that the only ones that add to give us negative 17 are negative 9 plus negative 8 is what's going to work out. So those are the two values that we're going to use to rewrite the middle term. So what we'll do with the original trinomial, when we rewrite the middle term, we're just going to make sure and keep the variables that are with the middle term. So we're going to keep CD. So we'll have 9 CD and then minus 8 CD. So I have negative 9 CD and negative 8 CD, keeping the variables from the middle term. We'll bring down the 6C squared and the plus 12D squared. And then we will complete our factor by grouping at this point. So between the first two terms here, we can factor out, we can divide both of these by 3, and we can factor out a c. So we have 3c, and we'll be left with 2c, let's see, minus 3d. So I'll still have this d over here. And then between these two, I can factor out a negative 4 between the numbers and then one of the variables d. So I have negative 4 and then one copy of the variable d. And then I will have a 2c, and then over here, if I divide this by negative 4, I'll get a negative 3, and then one copy of d is left. And we know that the binomial, if we've done this correctly, has to be the same. So we take that binomial out, that 2c minus 3d in parentheses, and then the remaining parts are 3c minus 4d. So this is my factorization. And let's go ahead and double check. So here we'll multiply the first terms, we'll get 6c squared. Outer will be minus 8cd. Inner will be minus 9cd. And last will be plus 12d squared. And then we combine those middle terms, 6c squared minus 17cd plus 12d squared. So that is the original trinomial. In this next example, we want to factor completely by first attempting to pull out a GCF, a greatest common factor. So notice that we do have a trinomial, but the first term here has a degree of 3 instead of something squared. So what that means is that I can't employ my technique from before. What I have to do, and what I should always do as the first step, is think about, is there a greatest common factor between all the terms? So absolutely, I can divide every term by a negative 4, and they all have an n in common. So the first thing I'm going to do is factor out a negative 4n, my GCF. So what'll be left here is an n squared. In the second term, I would have a negative 3 after dividing by the negative 4 and an n, so negative 3n. And when I divide negative 40 by negative 4, I get a positive 10, and I took out that n, so I have n squared minus 3n plus 10. But now, this right here is a trinomial with a highest power of 2, so we can try our technique of factoring this by thinking about the leading coefficient, which would be 1, so I'm looking just inside the parentheses, and that constant term 10. So I would be looking for two numbers that multiply to 10, but that add to that middle term, negative 3. So let's go ahead and see here. So they have to multiply to give us a positive, but add to give us a negative. So we would be thinking negative 10 times negative 1, which isn't going to work, right? That gives me negative 11. That doesn't work. We can try negative 5 times negative 2, but adding that together is negative 7, and that doesn't work either. So now that's it. I'm stuck. There are no further integers that multiply to give us a positive 10 that would potentially add to give us a -3. So sometimes people try to force it. The biggest mistake is really not being thorough about double checking that the product really does also add up to the number that you need it to. So sometimes people see like, oh, but 5 and 2, I can make that be a 3, but it's not the correct sign. So I need both of these to be negative to get positive 10 out, and these two numbers added together don't give me -3. So what does that mean? It means that we're done right here. So this piece of the factorization is prime, but the whole problem isn't prime because I was able to factor something out of it. I was able to factor out a GCF. So this would simply be my answer. So we did it a few times, but just to clarify, these were the steps to factor a trinomial by grouping. We determine if there's a GCF, and if so, factor it out of all the terms first. That's always step 1. We multiply the leading coefficient by the constant term, and we find two numbers that multiply to their product and add to the coefficient of the middle term. That's creating that table. And we use those two numbers to break up the middle term and rewrite the trinomial with 4 terms. And we use factor by grouping to factor the 4 terms.